If you clicked on this video, chances are you've seen this expression before and wondered what it means. It's called an integral, and even though it looks intimidating, it's not as scary as it seems. Well, mostly. In this video, we'll explain what an integral actually represents, we'll break down its notation, and briefly talk about how to solve integrals. So first, what is an integral? At its core, an integral finds the area under a curve. More generally, it turns rates into totals. If a function represents the height, then the integral gives the area. If it represents velocity, then the integral gives the distance. So the integral tells us the total accumulation, or the area of a function. But how exactly do we do that? Remember, to estimate the area under a function, we can use rectangles. The more rectangles we use, the better the estimate. This is called a Riemann sum, which I have an entire video on. An integral is what happens when we use infinitely many rectangles. The widths of the rectangles shrink to an extremely small amount, which we represent as dx, meaning a tiny change in x. At that point, the estimate becomes exact. The exact area is the integral. So that's what an integral is. How do we actually notate it? The integral symbol is like an elongated S, which stands for the sum. Think of all those little rectangles that are being added together. The total area is the sum of all those little rectangle areas. And what is the area of a rectangle? Well, the height is the function value times a very small width, dx. So really, just think of this like the sum of a lot of little areas. This right here is what we call the indefinite integral. A definite integral is the same idea, except we include bounds that tell us where to start and where to stop. So that's the notation. Now it's time for the really cool part. How do you actually find the integral? Even though integrals come from adding rectangles, we almost never calculate them that way. Instead, we use a shortcut called the Fundamental Theorem of Calculus, which basically tells us that integration undoes differentiation. So when you take an integral, you're looking for the function whose derivative gives you the original function. This result is called the antiderivative. For example, the derivative of x squared is 2x. So x squared is an antiderivative of 2x. But it's not the only one. The derivatives of all constants are 0. So if we added any constant to x squared, the derivative is still 2x. So when we're dealing with indefinite integrals, we have to make sure to include a plus c at the end. For definite integrals, we have a bound. This implies that the integral is equal to the difference between the antiderivative evaluated at the upper and lower bounds. The constants will cancel out, and that leaves us with the differences of the antiderivatives. Unfortunately, unlike derivatives, there's no single method that works for every integral, but they all rely on the same idea. Find the function that will produce this derivative. See? Not so bad, right? If you found this video helpful in any way, be sure to head over to my merch store at Dino101math.com. Get your mug and t-shirt today for 20% off when you use the link in the description. And now, keep working hard, keep learning, and subscribe.